Welcome back to I Know How To. If you're looking to build practical and tech and data skills, you're in the right place. Today, we're going to cover how to do a permutation check in Python using a linear efficiency algorithm. So here's the problem. We need to check for a permutation. So first, what is a permutation? A permutation is a collection of elements that, if put in order, would be all the unique elements needed to form a complete sequence. Now, what are we going to need here? We're going to need to return 1 if the values include a permutation and 0 if it does not. We're going to be given a list. So here are the 3 variables that I will define. Number 1, I will define n. N is the variable that will define the length of the list. To define the numbers we're looking for, we'll need to be within this range, 1 to n. The next variable will be covered tracker. Covered tracker would be a checklist that I will use to mark which numbers fall within the range 1 to n have actually appeared. It will quickly spot duplicates or missing numbers. The last variable will be a variable called distinct perm count. It is a running total of how many unique correct numbers we've found. If it hits n, if the value equals n, we know it's a perfect set, and then we will end the program. So let's get into the program using Thani. So here's the code. So I'm going to go ahead and walk through it. I'm in Thani, and here that n value that I told you would define the length, that will be n equals lena, and then here's the cover tracker. This cover tracker is an array. This array will be used to determine if we have checked the permutation yet. And this will be the distinct count. So let's go ahead and start to debug this. So you can use the step over. So first we can go ahead, and I want to show you, I'm starting out with the array equals 4, 1, 3, 2. This is a permutation because if we put this in order, 1, 2, 3, 4 would be a complete sequence. So let's go through the program and see what it does. So it defines the cover tracker. It initializes it to 0. 1, 2, 3, 4, 5. We have a length of the length plus 1. So the cover tracker would have 5 variables. And so if I step through it, I've defined the distinct perm count to be 0 because we have not, let me move this down, we have not assigned any counts just yet. So right here, the element the element will equal A0 because K right now is 0, and that would be 4. So we are going to, in the cover tracker, we're going to go 0, 1, 2, 3, 4, and this will become a 1. The reason why we're doing it between 1 and n, that's why we added cover tracker plus 1, because we're not going to be checking for 0 because we want the range to be between 1 and n, which is 4. So it'll be 1, 2, 3, 4. So let's go ahead and walk through it. So for element 4, 0, 1, 2, 3, 4, this is now going to be 1 because 1 is less than or equal to the current element, which is 4. 4 is greater than or equal to 1, and 4 is less than or equal to n, and n is equal to 4. So we're going to walk through it. And you're going to see that change. You see that change to 1. So let's keep stepping through it. So now we're going to decrease this distinct count to 1 because we have now found a distinct value in our permutation, which is 1 here because of we found that 1. So we're going to continue to step through this until all these equal 1, and then the counter will be, once this enters 4, we're going to know it's time to exit. So I'm going to step through it. Now we're on the element 1. So element 1 will be 0, 1. So now we're here on the 1 area. So in the cover tracker is going to be 0, 1. So we're going to make this one right here. So let's step through that. And when we finish this check, Did you see that change to 1? Great. So now we're in 2. What is 2? 0, 1, 2. It's going to be position 3, which is going to be 0, 1, 2, 3. So we're going to be looking to change this to 1. Let's step. And boom, did you see that change from 0 to 1? Great. So now we should be up to our distinct count here is going to be now 3 because now we have counted to 3. And did you see that change to 3? Let's step one more time. And that counter is now 4. This is all we need. Now we have 1, 2, 3, 4. That is a complete permutation that includes the total number of elements. And that will now check is the distinct perm count, which is 4, equal to n, which is 4, and it is. And it's going to return true. And as you can see, it's going to print 1 for true. Now, the next example is not a complete permutation. As you can see, it's 1, 2. Where's the 3? We don't have a 3. And we actually only have 3 in this, the length of 3. So I am going to step through this. I'm going to pull this down so you can see how it's going to step through. 4. So here, the tracker from 0 to 1. So now we're having 0, 1. 0, 1. 1 is the value, so that's 1. So it's going to update in the cover tracker 0, 1 because it found the 1. The next one is going to be 2 because remember we're skipping 0. We don't care about 0 because we only care about the range between 1 and n. So now we're checking 2, 0, 1, 2, 2, 0, 1, 2, and that's going to turn to 1. So now we're on 2. So now we're going to check the last element, and it is over. So that's all I have for now. It was that's all I have. I genuinely love creating these how-to guides. This channel is a hobby. Fantastic way to sharpen my skills. I'm excited for where I can transition these passions to a full-time role. Remember to subscribe for more tutorials and feel free to connect with me on LinkedIn. I love to hear from you, and I'll see you in the next video.